So good morning everyone. Welcome to Tamil Bhumi's online class. Today we are going to see data science and machine learning introduction. And after the video is complete, this will be uploaded into our Tamil Bhumi. This is our Tamil Bhumi channel where we upload the Tamil videos. Wherever we are doing in videos in Tamil, we'll do that. And now all these data science videos will be uploaded into Tamil Bhumi Technologies. There's an English channel where we'll upload all the technology related videos in English. So this session is going to be in English. Because of that, we'll upload the video in this channel, and you can just go to the channel and see the video once this session is complete. And talking about the session, today we'll see introduction to data science and machine learning. So this has been a big buzzword, and we are also done some sessions on this, and the interest is greatly increased in a recent time. So we wanted to give you opportunity to learn more, and whenever we start a course or whenever we wanted to do something, we want to help people to learn on their own. There are a lot of free resources, lot of mentors, lot of people who are available in machine learning and data science to help us. So you can use their help and you can use that path just to get the knowledge and get into data science or machine learning to switch your career. Those are the very shifting technology in the area recently, as you might have heard or seen in internet right today. So today we'll just start in that step and just step into the data science and machine learning. What is it actually, what it does do, and how to switch your career into that. And I'm not a techie person, so how can I switch into machine learning? I not know max to switch to data science? Such questions we'll answer today. And about the presenter, I'm not the presenter, I am the big data guy, and as you guys already aware, I'm a Spark, big data, streaming, those things I'm fully aware of. And here I'm also waiting as a student to start my big data science learning. And the presenter is Aritra Banerjee. He is a certified data science practitioner, and he's working as a data scientist in a reputed company, and he almost have around 7+ years of experience. So yeah, he has then faced a lot of problems in his work, and he solved it very well, and it was exciting to hear from him. So yes, that's it from my side as an introduction. So Aritra Banerjee, can you take over the session? Hello.
Yeah. Thanks, Aru. Thanks for the warm welcome, and good morning, everybody. Thank you for joining the session so early. I'm sorry to intrude into your sleep, but as we are all working professionals over here, these are the kind of sacrifices that we need to make, right? Waking up early to learn something new, right? So with that in mind, welcome everybody. Thank you for everybody for joining. Very good morning. And so as Arumugam introduced me, my name is Aritra Banerjee. I'm a data scientist with experience in working on data science projects across various domains, various clients, building insights, helping the business get a lift out of the current scenario, and that's what we do. And in today's session, I'll try to answer a few of the basic questions which I had when I stumbled across the term data science, and what all things I had to look for, what all things I searched myself, and what decisions I made before I became a full-fledged data science. So the agenda will cover a brief introduction to data sciences, what is the life cycle of a data science project, some use cases that we all know, and some use cases from my experience as well, how to become a data scientist, my journey through a data scientist, and to cap it off, what is the scenario of the job for a data scientist in India, right? Let's keep the complexity level of for this particular session to a bare minimum. So this is basically our target is to help people who are aspiring data scientists or who are novices in the field of data science to just get a foot into the door of data sciences, to understand what data science is, what is it all about, what are the skills that are needed, and so that's the agenda, that's the focus area of today's session. So what we'll do today is I've divided the session into two parts. So the first part is I'll go over all the topics which I've listed over here, and in the second part, we'll open the floor to questions. And we'll not have a straightforward question answer session wherein you guys will ask questions, I'll answer. No, let's not have it like that. So I'll try answering all the questions that you have, and in the end, I'll open the floor to everybody. So, for example, if a particular question I answer, then I'll open the floor to anybody else who might have a better suggestion answer, or who might have something more to for more flavor to add to my answer. In that way, we'll end up everybody as gaining some like with good takeaways from the this particular session. And let's keep it interactive, guys. Feel free to interrupt me at any point of time you want. Let's not be me who is the only person speaking, because like once you go back and once you watch the recording, if my voice is the only voice you're hearing, then you'll probably doze off because I'm not as melodious as Kishore Kumar, right? So let's make it interacting, let's make it interesting. And so yeah, let's start off with the first question. What is data science? Now I'm not going to give you some mucked up definition of data science which I learned from Wikipedia or Gartner, right? I am going to explain to you what data science is to me, what I understood, what I have experienced to be data science. So for me, first and foremost, data science is all about finding the truth, right? We explore massive data sets, we slice and dice data, we uh, mine data to its like finest possible level, and come up with insights, and come up with ideas to solve business problems, to give business a lift, a competitive edge over its competitors. So that's for me, that's what data science is. And also I feel that data science can be divided into two parts. One is science and the other one is art. Now it might be a bit confusing as to why it's science and why how I have mentioned art over here. So let me clarify. Now, what do I mean by science in data science? Science in data science basically means drawing insights, whatever drawing insights from the data. So just small question is, am I audible to everybody?
Yeah, audio is clear. For
Yes.
somebody is deficit. Yeah, go ahead.
Okay, okay. Thanks. So just a second. I've started the share again.
Yeah, here it is.
Okay, okay. So to continue, what do I mean when I say data science is a science? So data science is all about like uh, slicing, dicing, and exploring the data, right? So we explore the data in various ways. We use several data mining techniques like machine learning, uh, deep learning, artificial intelligence, natural language processing, statistical modeling, and whatnot, right? So therein comes the science part. Now, what do I mean by art in data science? Now, you have to understand that data science is not only about mining data and not only about coming up with the insights, right? You have to represent that data, that your insights in a form in which a layman can even understand, right? So, for example, let's take a quick example. So, the CEO of the company that you're working for has requested you to predict the sales for the next financial year, right? So for that, you have gathered all the previous year's sales, you have applied several forecasting methods, and you have finally selected a model which gives you the best output, right? So how will you represent, or how will you present your findings to the CEO? You cannot just say that, okay, sir, I have selected these many data points for my experiment. I have used these many models, and I finally believe that model number three is the best approach. Why? Because it gives the least error, it gives the best fit for our algorithm, and this is the sale for the next 1 year. He will not understand a single word that you say, right? Because he's a business person, right? So you have to represent your findings in a way that he will understand. And given a point that if you are in a meeting with a business person, probably he'll have like 10 to 15 minutes time for you. In that time, you have to explain your inside. You have to explain what process you took. You have to explain what challenges you faced and what is your solution to the problem, right? So all of these things to be done in just 15 minutes. So you have to build compelling ways to represent your data, represent your findings, right? So therein comes the art portion, wherein you have to represent your findings in a way which is very clearly understood by a person who is a non-technician person, who is a complete layman to data sciences, right? So to cap it off, data science is nothing but doing a deep dive into the data, uncovering patterns, uh, uncovering patterns, uncovering potential about business growth, and help in turn applying specific methods to help solve their existing business problems. And business problems can come in varied ways, starting from as simple as forecasting your future sales to SE, stuff like SEO, building your presence in the global market and whatnot, right? Okay, so moving on, I'll give you a brief about what are the stages in a life cycle of a simple data science project, right? The first and very important stage is the problem definition. So a business can have several problems, and out of that, you have to identify which problem you are trying to solve over here, right? So the definition of the problem is very important. You need to limit the boundaries in which you are going to work, or otherwise you might end up with nothing, right? So next step comes the data exploration. So you need to uh, find source of data which will help you work on the problem at hand. So, for example, let's take a simple example. Particular company, say a particular bank, they need to know they've provided loans to say around 100 people, and they need to know how many of these people will falter on repaying the loan, or how many of these loans are going to be bad debts or bad loans, right? So for this particular exercise, what kind of data do we need? This particular exercise requires data of past, like past repayments of the customers, and you have to gather that specific kind of data. You cannot just say that, okay, I have the 100 customers social media activities, now I can decide who will repay the loan or not. No, that will not work. You have to explore for the correct data source which will help you in solving this particular problem, right? The next stage is the data preparation stage. Now, data preparation stage, what we do is that, so for example, we have collected, say, going by the same example, we have collected the past history of, say, around 200 customers. Now, out of these, we are interested in only 100 of them, because we have given loans to these 100 people. So we need to weed out all the kinds of data which we will not require in our current study, right? So that's one part. Second part is, out of the available data which we are going to use, there may be some anomalies, there may be some outliers, there may be missing values. So all these things you will have to treat before you can go to the next step. So basically, cleaning the data, parsing the data, missing value analysis, and all these kind of things, they come into the third stage. The fourth stage is actually applying, modeling the data, or applying machine learning, deep learning, neural network, whatever you want to apply based on the problem. This is the part where you do the modeling part, right? Next is the model validation. Now, once you have built the model, now you will want to test the model on another data set to make sure that the model is working correctly across the varied kind of data sets, right? So that's called the model validation. And finally, when you're done, you're going to implement the model to the production environment and continue with the maintenance. So 6 stages, very short: problem definition, exploration, and data preparation. These three are the main stages of a data science project. So you must have heard, folks who are already familiar with data science terms, you must have heard jargons and buzzwords like machine learning, artificial intelligence, natural language processing, deep learning. So all these are actually part of the modeling phase, but trust me, that constitutes hardly 10 to 20% of a data science project. Most of the work goes into identifying the problem, exploring the kind of data set, and cleaning and preparing the data for our modeling purposes, right? So these three steps are the most important steps in a data science lifestyle. So I'll quickly pause here. If any of you have any questions.
Hello.
Yeah, hi, go ahead.
Yeah, thanks, Haridra, for your valuable explanation. And here I have doubt. So the machine learning comes in the modeling part only, right?
Machine learning mostly comes in the modeling part, but we can apply little bits of machine learning in the data preparation phase also. So, for example, there's a technique called wherein when some few data points are missing, so you can apply very simple regression algorithms to come up with the missing values as well. But yes, the bulk of the machine learning, the predictive, or say any kind of descriptive analytics part comes in the modeling part portion.
Okay, thank you.
Okay, Aravind, so what are the technology that we use? So we in the market we have so many technologies. So here, so complete for data science, for the problem definition, data exploration, data preparation, and the validation modeling. This all combined. We do have any one single solution who can provide, or do you have separate tools?
Yeah, so I'll come to that in later slides.
Okay.
That's a very good question, actually. We do have a slide later on wherein I'll cover all this particular topic, right?
Yeah.
Okay, good question, but thank you. So any other questions, or should I move on?
So what is the data scientist, like data analyst role here? Where do they?
That's a particular gray area because data analyst and data science, these roles are they can be overlapping, right? From my experience, what I've seen is that data science currently in the market, uh, they are mostly full stack data scientists, right? They start from uh, the first stage of the life cycle, the problem definition, and they work on the project till the implementation and maintenance, right? Data analyst is actually a term which many companies have come up with. So a data analyst, the base level of a data analyst is uh, simple data mining, SQL mining, coming up with descriptive insights, building charts, and all. But in other companies also, it varies from company to company. In other companies also, few of the companies, the data analyst can also work on some modeling stuff as well. It's a gray area right now in the Indian market. Some people refer to a data scientist as a data scientist. Some of them refer to as data analyst. But from a broad overview point, a data scientist is a person who is well versed in stuff like statistics, machine learning, and so on. Data analyst is a person who is more experienced in doing SQL mining and build like descriptive insights.
Okay, thank you.
Okay, moving on to the next slide, I'll discuss a few use cases which are prevalent in data science in the industry right now. So I think everybody over here are familiar with Netflix and Amazon, right? These are two of the biggest websites that we use. Amazon for as an e-commerce platform, Netflix for a video streaming platform, right? You must have noticed that whenever you view a particular like movie in Netflix, the next time that when you enter or when you log into Netflix account, you will see that you will have suggestions or recommendations based on your what kind of movies you have watched, right? Similarly, when you open Amazon, when you have been using Amazon for quite some time, you'll see that you get or whenever you're browsing a product, you will see that you get recommendations for similar kinds of products, right? So these are nothing but recommender systems which these particular websites or these particular companies use to to introduce a particular customer to several to new kinds of products or services that they have based on how they have previously interacted with these systems, right? That's one classic use case, and that's the use case that I speak to all like talk to everybody about whenever I'm talking about data scientists. So Amazon and Netflix, the recommender systems are far superior than any of the current recommender systems. Next is superstores. You might have seen that whenever you visit any kind of shopping mall or any kind of superstore, say Big Bazaar or any kind of chain outlet like that, you'll always see that several kind of products are grouped together. Say, for example, bread and milk, or say, and by grouped together, I mean that they kept in, say, adjacent shelves or something like that. Bread and milk, or say eggs and bananas. There's no similarity at all between an egg and a banana, right? So why are they grouped together? Because that's what these people have seen their customers buying, right? Milk, bread, or say egg and bread, or say banana and bread. These are staple items for your breakfast, right? So inadvertently, whenever a person buys bread, he or she will end up in buying either milk or say banana or say egg as a part of their breakfast. So to increase the sales of the second item based on the purchase of first item, these similar kind of items are grouped together in the supermarket. So this is a classic case of what do we call a market basket analysis. So these are two of the like best known cases in data science market currently. Something from my experience, some of the projects which I have worked on. Firstly, I had worked for one of the leading handset chip manufacturers, say the chips that we use in our smartphones. So they wanted us to build a particular model wherein uh, uh, they can know or they can predict how much sales will be there in the coming 1 year. So what happens is that these chip manufacturers, they need to start their production cycle at least a couple of years before the new handsets are launched in the market, so that they are able to supply the handset manufacturers at an adequate point of time. So they need to know at least a couple of years before that what their sale is going to be in the next, say, 2 to 3 or 4, even 5 years. So we had helped them by building a way of building a predictive forecasting model that will tell them or that will inform them of how much sale will be there they have in the next few years. Uh, Another interesting problem that I had worked on is that a particular client, it was a business to business client, and they had a large base of customers, and out of them, they wanted to offer few customers, around say 10% of the customers, a loyalty rewards program. Right. So for that, somebody is currently not on mute. So can you please mute your audio, please? Yeah.
Yeah,
Thank you.
yeah.
Thank you so much. Yeah. So this particular for this particular use case, what we did is that we had requested the entire transaction history of their customers, and we had applied an RFM model, that is the recency, frequency, and monetary value model on these customers. So what that does is it gives a particular customer a weightage based on how recent their purchase was made, how frequently in the last, say, 5 months they have purchased from the company, and what is the average monetary value, what is the average value of each of the purchases they have made. And we had ranked the customers based on this particular metric. And we had suggested that the client sorts the customers based on the rating and offer the top 10% customers the loyalty rewards. Again, we had there are a couple of other projects which I had worked on, also helping a client launch a new product in the market. Uh, we did some market research to help them out with to understand the market, to understand the pricing, to understand their competition in the market, and etc. And also currently there's a very interesting project that I am working on, is that we are trying to classify the online news or the quarterly news of several companies, and we are trying to assign them a sentiment, whether the particular news is talking positively about a particular company, or is talking negatively about a particular company. The goal over here is to help investors understand what the current scenario is in market. So, for example, if an investor is investing, say, it's going to invest in a company, say company A, but on the very day that he's trying to invest, he gets news saying that company A's CEO has resigned. So that will definitely be a negative item, right? So that will trigger a particular alarm in the investor's dashboard, and he can take his call accordingly, right? Yeah. So these are few of the use cases which I have come across in data science. Right? Now, moving on, we have spoken about what data science is, how data science can help a business. Now, let's see who is a data scientist is. I came across this very interesting uh, definition of a data scientist sometime back when I was actually uh, striving to become a data scientist myself. So it goes like this: the data scientist is a person who is better at programming than a statistician, and better in statistics than a programmer. So this is a very unique definition that I had found, and I still have this particular definition like printed across my wall in my room. And this particular Venn diagram. So these, in short, will tell you what kind of skills you need to become a data scientist. You have maths and statistics knowledge, you have the domain expertise, you have programming skills, machine learning, research, and in between everything is data science. So I know for someone who is very new to data science, this particular slide will probably confuse him or her even more. So let's move on to the next slide, wherein I will explain in detail what the skill sets you require to be a data scientist, right? So for a person to be a adept at data science, the first and foremost skill that he or she needs to have is SQL or ETL knowledge. Mind you, currently 99% 90%, I won't say 99, say 95% of the companies still rely on traditional RDBMS to host their data. So for basic data mining purposes, or for basic insights and slicing and dicing of data, we still use SQL at large. So SQL skill, or say ETL knowledge is very, very important if you want to be a data scientist. So if you already have that particular knowledge, as I'm sure many of you might be having, so that's one checkbox is already ticked for you. Next, we need to have very good knowledge of programming. So few of the most commonly used programming languages in data science are Python and SAS, right? Now, this is where I would like to point out the question which one of you had earlier asked, that is there a holistic package, is there a all-in-one package which we can use for a data science life cycle, right? So yes, currently SAS provides an environment in which you can host an entire data science project, starting from your business problem identification, ending at implementation and maintenance. Everything you can do in a SaaS environment. SaaS has several tools for that purpose. It has SAS E-miner, which is a classical predictive modeling tool. It's basically a drag and drop tool wherein uh, use you can explore and prepare the data. You can apply data modeling. You can test your models, and you can even implement those models using SAS E-miner. And apart from that, SAS also has a visual aid. SAS V is called SAS VA. So it allows you to extract your data from SAS E-miner and build compelling visualizations on top of it. But SAS, again, SAS comes is not does not come cheap. It's quite an expensive tool to use. And SAS tools are mostly used in the BFSI sector. In the other sectors, say like retail, commercial, e-commerce, telecom, FMCG, these sectors still use many open source programming languages, with Python being the most important of it. R R is used mostly in the academia. It's used mostly in colleges and universities and for other research purposes. So right now, at least I would say around 70 to 75% of the data science professionals that I have met are well versed in Python, right? So next we have another very important skill set that we need to have is data visualization. So as I told you, why data science is an art. Data science, we need to visualize the data, and we need to build compelling visualizations for the end user to understand our insights and take corrective actions from them, right? So data visualization is a very, very important skill that we need to have in our toolkit. A few important technologies that a few important softwares that we use in data visualizations are Tableau. Tableau is used extensively because it's very, very user friendly. It's also a kind of a drag and drop tool, and why it's used so extensively is because uh, you don't need to be a technical person. You don't need to be a techie to use Tableau. Even business and end users can also use Tableau with great ease because it's that user friendly. Now moving on, next item that we need to have is a good working knowledge of statistics. Now, here I'll address one a very important question that many of us have, is that to what extent must we learn mathematics, or to what extent must we learn statistics to become a very good data scientist? See, statistics is to become a data scientist, you just need to understand few very basic concepts of statistics. Those are the 5-point classification. What is the mean, median, mode, standard deviation, variance, and then you will come your hypothesis testing, say A/B testing, and F tests, and chi-square tests and all those kind of things. So if you have a proper working knowledge of what these tests are, it'll be very easy for you to interpret the results of your machine learning algorithms, because the machine learning algorithms, whenever they will give you the output, you'll find that there are several items called R square, adjusted R square, your F test, your P value, your chi-square test, depending upon the kind of algorithm that you have used. So interpreting these particular values will require a good knowledge of statistics. And where does the maths fit in? The maths, if you are mostly working on machine learning algorithms, you will not need to know anything apart from your usual statistics. Maths or core mathematics, derivative and calculus and all these kind of things are more needed in when you're working in deep learning or reinforced learning. When you're building the neural networks, GNN, RNN, all these kind of things, understanding and interpreting or building your neural networks or random forests they will require a good understanding of derivatives in mathematics. But deep learning and reinforced learning and all these kind of things, they are not yet that relevant in the market as of now. Only very few projects and very high end projects require a deep learning module. So currently, if you're looking to build your career in data science, or if you're looking to gather the skills, I would suggest having a good knowledge of statistics, the basic statistics, and the hypothesis tests should be enough for you to cover, and should hold good while you are working on the machine learning problems, right? Next, the next item that you need to know is machine learning. So machine learning, when I talk of machine learning, I'm not limiting myself to the high-end algorithms like SVM or say your decision tree and all those kind of things. No, machine learning is as simple as a regression model. I'm not sure how many of you are familiar with the term machine learning or regression models. So basically, machine learning encompasses all kinds of predictive models that you use. It can be as simple as a linear regression model, or it can be as complex as a highly branched decision tree or a random forest. Right? So if you have a good knowledge of machine learning, or if you have a good knowledge of at least say 3 to 4 algorithms of machine learning, that should be enough. And the last and the most important skill that the data scientists need to have is problem solving skills, or thinking on your feet, thinking analytically. So whenever, as a data scientist, you day in day out in your work, you will face some challenge or the other. It's not easy because the data science industry is not yet mature. So there are many kinds of things which we come across for the first time in our life. So you need to think on your feet. You need to be able to solve problems quickly for to be a successful data scientist. And so these are few of the must-have skills that you need to acquire to be to start your journey as a data scientist. Now, there are several other good to have skills which you can add to your CV. Uh, one of the skills is big data. So currently, as you guys are aware, the industry is slowly trying to move out of the traditional DBMS and move into big data space. It's not fully transitioned yet, but yes, there are some companies who are actively working in big data, and as such, they have a lot of opportunities in for big data engineers, for big data developers. And as a data scientist, if you are well versed in at least one of the big data technologies, say for example Hadoop, or say for example something like Spark, it'll add a very good weightage to your CV. Uh, Personally speaking, for me, we have started using Spark. We used to in our currently in the project that I am working in, we used to host our database in SQL Server, but since last 1 year we have migrated to Spark, and we are currently using Spark as our daily driver. So that's how you see, that's how the industry is slowly trying to move away from the traditional database. Traditional database is still there because it's the bread and butter for the data engineers. But again, having a big data skill will help you in the long run because the industry is slowly transitioning to big data. And again, the last skill that is a good to have skill is knowledge in any one of these three areas, be it deep learning, be it reinforced learning, or be it natural language processing. Why I always stress on natural language processing is because slowly we are moving out of our traditional database, right? And we are trying to explore different other kinds of data sets as well. So we are trying to explore, we are trying to gather insights from textual data. We are trying to gather insights from the photos, videos, and so all these kind of things. Out of this, the textual gathering information from textual data is the most prevalent. So natural language processing will help that in the long run. I'll quickly run through this particular slide. Most of you might be aware of what I'm trying to talk of here. Now, how do we acquire these skills? First and foremost, the simplest way to acquire these skills is self-learning. Learning through MOOCs. There are massive online open courses available. Almost everything can be found nowadays in YouTube. I've mentioned a few channels over here, YouTube channels which you can follow. Edureka, Simply Learn, Khan Academy. These are pretty good. Khan Academy statistics, and for example, is a very good place to start learning statistics for you to become a data scientist. Kaggle, Analytics Vidya, they are certain servers who host data sets and who host challenges and hackathons for data science. It's a these two are very good platforms for you to get some hands-on experience in data science and do some like real life work in data science. Other courses are there. There are some executive courses and certifications. These kind of courses are part-time, and you can enroll in these kind of courses while you are working as well. ISP Hyderabad, IIM Lucknow, these are a couple of premier institutes who provide business analytics course, online business analytics courses. There are also fully online courses available. Few of them are in Coursera, few of them are in Udacity, which you can pursue. And last is a full-time master's degree. A full-time master's degree again can be of two types. It can be an online, like the ones which Upgrad and Jigsaw Academy provide, or it can be a full-time course wherein you stay devoted to your college for a couple of years, earn your degree, and then apply for a job again. Couple of institutes who provide very good top-notch degrees are, firstly, there's a degree in business analytics which is given jointly by ISI Kolkata, IIT Kharagpur, and IIM Kolkata. This is a full-time 2 years course. It's one of the most premier courses that you can find in data science in India. And another very good course which I know of is the MBA in Business Analytics provided by Great Lakes Chennai. Now that you have a working knowledge, a theoretical knowledge about data science, now whenever you step into interviews, most of the time the interviewers will ask you, what experience do you have in working hands-on in data science? This is something which I had faced a lot while I was being interviewed across several companies. Now recruiters want to know what experience you have in handling several kinds of data sets and applying several kinds of learning models, and in applying and how good you are in solving problems at your feet. Now, there is no particular way to garner experience other than to practice, to go on practicing how to solve several complex business scenarios. The one way you can do it is by trying to solve the hackathons that are hosted in several websites like I mentioned Kaggle, I mentioned Analytics Vidya. Practice as much as you can, work on as many varied kinds of algorithms that you can, so that at least when you are trying to apply for a data science job, if you're not in one already, if you're trying to apply for a data science job after doing a course like the ones which we discussed about in the previous slide, you can at least defend that, okay, I have the theoretical knowledge, I have the working experience as well, so I am a good enough data scientist, right? Now, I'll just give you a brief about how I stumbled across the data science world, what steps had I taken, what difficulties I had faced to become a data scientist. So, I was introduced to the world of data science in my very first company, wherein we were tasked with a very simple classification problem. We were trying to classify our customers and based on the kind of assets that they have with the client, and trying to bucket them in several categories. That was the very first project of data science that I had worked on. And I did not have much clarity on actually what uh, that particular project was. At that point of time, I thought it was a simple ETL problem, but it was not. Later on, when I realized that, understood that this is a far superior, complex, more complex problem, then I decided to pursue it. In my second company, I started working directly with the business end users of the client, and try to understand what kind of business problems they are facing. How are we helping as analysts and data scientists? How are we helping them to solve these business problems, and what all methods that we can apply to solve their problems? And therein I decided that I need to know something more. I need to understand this particular field in more detail. So I did some research online, and I found the course about ISP Hyderabad. It's a 1 year course. I think they have now extended it to 1.5 years. It's a part online and part in campus course, which I had to take. Uh, when we were taught several aspects of the business analytics, what stood out for me in during that uh, like while I was in that course is how they are integrating these data science concepts into real life business problems. So almost for every assignment we were given a real life business use case, and we had to apply our machine learning or our data science knowledge on top of that business use case and try to solve that. So that particular experience that particular experience was something which transformed me as a data scientist. And then currently I am working in a company wherein we are treating several particular we are treating several clients, and we are helping them apply data science problems. uh, we are helping them to apply data science algorithms to solve their business problems. uh, Quick info on the condition of a data scientist, or the condition of data science jobs in India. Currently, there are around 97,000 job openings for data scientists in India in 2019. This has risen by almost say 50%. It's a flat 45% jump since last year, since 2018. Machine learning is the most sought after skill set that data scientists must have, and around 75% of the data scientists are proficient in Python. Now, out of them, 36% believe that a proper formal education, say a 1 year course or an online certification or an online course, is beneficial, while 39% believe that the massive open source courses are better. So you see that almost 80% of the data science crowd believes that there has to be some sort of education. You have to go through some sort of guidance to become a good data scientist, right? So uh, that brings us to the end of this particular session. I hope that it was a fruitful one, and I would now like open the floor to any questions that you might have. And yeah, so let's get started. Any questions?
Okay. Aravinda, this is Vinu here. Thank you for your detailed information. So, do
Thanks.
you have any technology, inbuilt technology, so where we can build all the scenarios regarding to that, all mm, the algorithms? Do you have any current technology?
See, currently, as I told you, if you want a full-fledged package, SAS provides the same. SAS E-miner is the uh, SAS SAS E-miner is the software which many BFSI clients use to drive end-to-end data science problems. But apart from that, I would say around 90% of the companies they use open source softwares like R and Python. And for
Okay.
visualizations, they mostly use Tableau. But again, if they want to go for the open source option, they have Power BI as well. Personally, for me, whenever I'm working on individually on some project at my personal laptop, I mostly use Python, and for visualizations, I use Tableau.
Okay. So, yeah, sorry, but the scenarios, right? So, algorithm. Suppose I want to do some prediction.
Hmm.
So, how like where we will write these codes in the Python or like where it will be? We'll be having the algorithm. Okay,
Right,
in
right.
mathematical side or something that we
Hmm.
have to convert it to code, right? For
Correct.
that, we'll use this R or Python, or do you have any other?
No, mostly for building the machine learning algorithms, the code is written in R and Python. They have specific packages,
Okay,
specific
okay,
statistical packages, wherein all
okay,
these functions are already pre-written, and you just
okay.
need to call that function. Say, for example, they have a specific uh, function for decision tree model or a specific function for regression model. So you have to call these functions, and it will return you the output. But the
Okay,
coding
okay.
coding is mostly done in languages like R or Python.
Or at Python. So
Yeah,
we need to prepare the data according to that algorithm. Then
correct,
it will pick it and like give us the result.
correct. That's correct.
Okay, okay. Thank you.
And
Hi, Aridra.
yeah, hi.
Yeah, actually, this is related to my scenario. Actually, I'm having 8 years experience in ETL tools like DataStage and Informatica.
Uh-huh.
Last 6 months, I have been preparing for a big data tools like Hadoop and Spark.
Okay.
So, is it advisable for me to go in the data science area, or so now I'm a bit confusing. What next step I can take? Can
Yeah. See, you are talking about two niche categories over here, right? Both big data and data science, they are in a way mutually exclusive and also in a way similar also. As I told you, uh, as a data scientist, it's very good if you have um, an exposure in big data. But what I would advise you is that you just pick one line and stick to it. So if you are picking big data, you can pick big data and become an expert in that. Or if you are picking data science, you can pick data science and become an expert in that. So these two areas are huge, and they are both equally rewarding. Big data has a lot of potential in coming years because now almost all the because big data, most of big data is open source, right? All the companies are currently trying to move away from the traditional RDBMS into big data space. So there will be a lot of potential for you to grow in that particular area. Similarly, in data science as well, since now data is so readily available, companies are using these data to drive their business growth and drive their business insights. So data science in itself will also give you a very good career boost. So what I would say is that since in the last 6 months of your career, you've already been into big data, I would suggest that continue to do that. And on the side, you can look up some you can on your leisure time just go through some data science stuff. If that interests you, well and good. You can build both of them simultaneously, or else I would say stick to one particular field and excel at that, because
Yeah.
you seriously can't go wrong with either of these fields, two fields. Big data and data science are equally rewarding.
Okay, thanks for the great advice. Thanks.
No problem. So if anybody else in the audience has any suggestion regarding this question, please feel free to add to my answer. I don't want to be the only person speaking over here. We can all gain knowledge from each other, experience.
Hey, hi, this is Sangeeta. Even I am a ETL person and I moved into big data. And actually, I want to study data science, but I I'm lagging of it requires more effort, at least from my side. So I'm not able to get time to do that. But I often read most of the stuffs like then and there in all the sites, and some courses also I'm going through. So I have questions. For example, in a market standard or a business, or like how you are doing in companies. That is what I want to know. For example, you have some problem and you need to find it out. Like which side it will go, whether it is a regression or classification or where it is. And once you find it out, the problem is related with regression, okay? And regression is mapped with a couple of models like linear regression or multilinear, something like that. For example, regression is having for example, I say for regression, we have some 3 set of models, and out of 3 set of models, we need to find it out which is best one for the data.
Correct.
So, and this is my first question. For example, regression, we have only 3 kind of models, and out of 3 models, which one is best? That is what I need to find it out. And the second question is, I can see now data science become more advanced, and we no need to write a code. I mean the exact mathematical algorithms. It is Python is having all kind of functions. We just need to call it mean or median or complex functions. So I heard we can write models within 10 lines in Python.
That's
and
correct.
so it looks simple, but when you start putting effort to understand to build it is very complex. So are you able to understand my question?
Yes,
Sorry.
I think let me answer your questions one at a time. So regarding your first question, so you wanted to know that how to decide which particular model is best suited for your business problem. Is that right?
First they'll provide you the data, and how you'll find out which part it will fall into.
Got
I mean, regression or classification, and then which model, and then we have already a lot of functions. We just need to call the functions. So how? Yeah, this is my question.
Yeah. So first and foremost is what you need to do is that you need to understand what kind of a problem you're dealing with, right? Say for example, if your problem is as simple as predict the new price of a product, and they've given you say set of 100 records at a bare minimum. So price of new product, what is that? That's a numerical quantity, right? You need to arrive at a particular numerical quantity, say something like 19.50 or $29.99, something like that. So when you need to predict a numerical value, you need to apply algorithms like regression, be it a simple linear regression, be it a multilinear regression, and whatnot. However, if they ask you to say, if the business problem is something like classify or categorize my customers based on their behavior, that's a pure classification problem, right? For that, you need to apply something like say clustering, or something like say yeah, I think clustering would be the most appropriate solution over here. Then say something, you are working on a business problem which requires you to say whether a particular customer will default in paying his loan or not. So the output variable will have only 2 values. Yes, he will default. No, he will not default, right? So in cases like these, you can use classification algorithms, something like logistic regression, something like decision tree model, right? So based on so how you understand what kind of problem you are facing, that will define what kind of algorithm you are using, right? Now coming to second part of your question, now that I have understood that, okay, this is a classification problem, the output variable will have only two values, 1 or 0, right? Or yes or no. What kind of algorithm do I apply? Do I apply a logistic regression? Do I apply a decision tree? Do I apply SVM? Or what kind of model do we apply? Usually what we do is that we apply, once we have prepared the data, we apply an, several kinds of models. We apply, we try out 3 to 4 models at least, and then based on the accuracy, based on several parameters, we choose the best fitting model. So it's not like that once we have identified that, okay, this is going to be a linear regression model, then we only apply one model. No, that's not it. We apply an ensemble of several models, and based on the best fitting model, we choose which algorithm we will be going forward with. What happens in also other case, what happens is that, say for example, we are not able to find which model is the best fit. So what we do is that we create an ensemble of it. So we have say we have built 4 models, and we see that out of the 4 models, one model's accuracy is the highest. So we will give the output of that particular model the most weightage, and the other 3 models will have less weightage while calculating the final output. So we create an ensemble, and that's how we come up with the final model. Does that answer your question?
Yeah, yes, and finding out the problem statement, like developer work it is, they will find it out like this will fall into the classification and this, or a business analyst, they will find it out and they'll provide you the details and you will work on the data and you'll create the model.
Hello. Yeah.
Yes, Aru.
Yeah. So this is kind of like more depth question. So we'll take it offline. And for now, we'll let's focus on the overall general question. And this will take offline after the class.
Okay, I agree. One last question. So, do we have any proper online for basic mathematical?
Yeah, sorry, come again.
What is the basic online or a YouTube channel for basic mathematics, which is required for data science?
For statistics, I can recommend you Khan Academy. Khan Academy statistics courses are really nice. Apart from that, you can also visit channels like Edureka or Simply Learn. They also have very good foundational courses in maths and statistics.
And also, we are also planning to start like putting more data science classes videos in our channel, also in English channel, obviously. So you can follow that. And we are also planning to start a course from July, full-fledged course. So if anyone is interested, you can also join that as well.
Yep. Thanks, bro.
Thank you.
Thank you. So I think we have time for one last question, right, Aru?
Yeah, fine.
Yeah. So one last question. If anybody has. Okay, I think we are good. So with that note, thank you everybody for joining. And there's one last word of advice which I would like to give to everybody, all the budding data science aspirants, is that the data science world is a huge ocean of opportunity, but you need to know what to pick up from that vast ocean. So you might be overwhelmed with so many things around you. Say some people are learning NLP, some people are learning deep learning, somebody is talking about reinforced learning, somebody is talking about neural networks, and but what I would suggest you is that go with the very, if you're learning on your own, start with the very basics. Start with simple statistics. Start with understanding the customer's problem. Start with understanding the scenario at your workplace, for example. Pick any kind of scenario from your workplace and start studying on it. Start understanding the simplest of machine learning algorithms. Start understanding how you can clean and parse a particular data which and you can feed into a particular model. Start with basic this like start by mastering the basics and only then jump to the next level. If somebody who is a novice in data science wants to learn something about deep learning or neural networks at the very start, he will probably fail and he or she will end up with nothing. So my advice to and every one of you on this platform, and this is something which I had also faced, start with the basics and build your way up. Build your way up to the top. Data science is, as I've written in this particular slide, is a huge ocean of opportunities, and you can only grow with it in time. So with that, yes, thank you everybody for joining. Thank you, Aru, for helping me host this session. And have a nice day, everybody.
Yeah, thank you. Thanks, Haritra, for such a patient uh, session. So yes, as I said, this video will be uploaded into this YouTube channel, Tamil Umi Technology. You can go through, and there will be more videos upcoming in this as a data science. And as I said earlier, we'll start our course from July 5th. So if anybody is interested to join a full-fledged course, so you can contact us using our WhatsApp number or WhatsApp group. I hope you are already in a WhatsApp group. So yeah, with that note, thanks everyone. Thanks everyone for attending in the morning of Wednesday. So thank you. We'll meet you in the next session. Keep following our group for more updates in the next upcoming sessions. We are planning for more. Thank you.
Thank you.